Welcome back to this generator reverse engineering project. Life got in the way and everything got delayed for quite some time, so now we're back to it again. So I'm going to do a quick review. Shown here is the stator with this power cable connections. Notice that all these windings are red in this particular view. That's because this is one phase of the two phases of the generator. This one phase has the red windings. It's got the two red crossovers between 816, 717 on down the line. And it's got two red crossovers from 3 to 21. If we go and look at the other set of windings, the blue power windings, same thing. We have blue crossovers from 9 to 15. No blue crossovers from 3 to 21 because the winding is missing. And we got the blue crossovers, two of them for each sequence of windings. So it's good you look at this generator as if all 8 of these windings, actually all 7 of these windings, equals one phase of the generator. And then the other 7 windings is the other phase of the generator. So let's take a closer look at this. As part of this review and to further enforce our understanding of the generator, notice that these dots over here have been changed. This drawing's been updated. This is drawing B, created today. And the dots were in the wrong place. They were down here on 15, 16, 17, and 18. They should have been up here on 10, 9, 8, 7. Now what we can see is the note down here says dot indicates the current flow direction out of the coil on that alternation. So the first alternation, current's going to be going up, the dot's out of the coil. Current's going to be going up in the red phase, and it's still going up in the other 3 windings of the red phase. The red phase is connected to white 360 hertz and the red 360 hertz. At the same time, the other phase also has current going up this way, across, up this way, all additive for the blue phase, which is blue 3 connection, and the black 3 connection, which is a 60 hertz connection. So what I want to point out here is that these 2 phases, the red phase and blue phase, are in phase. The voltage generated by these 7 coils, these 4 and these 3, plus these 3 and these 4, generates the same voltage, 120 volts AC, and they're in phase. What's different is that we connect to opposite ends. For the red phase, we'll call this the hot side of the line. This will be the common side of the line. On the blue phase, we connect at the opposite, the hot side of the line. Down here's the common side of the line if you're talking in typical AC terms. So the coils are in phase, therefore the windings should be relatively simple. And if you want split phase 220, you simply use this for the one phase of 220 and this for the other phase of 220. And these would be commons for the 220, these 2 points here. So that's a quick review of these 7 coils and how they work in series. Just remember that everything's happening simultaneously in both sets of phases, which I call them. The red phase and blue phase, everything's happening identical in both of them because they're in identical slots. They have to happen exactly the same. So why were these 8 slots over here labeled improperly with the dot? Well, the reason is that's a physical orientation of how the current would flow when I had it wrong. The reason it was wrong is because if you take a look at the rotor, you notice you got a north face and a south face. So the 2 faces have different results on the windings they're cutting. So therefore that reverses what's happening in the opposite set of windings, the opposite set of 4 or 3 windings, whichever the case may be. So this is why I mislabeled this. I didn't consider the fact that the armature head was different on these slots at the same time. Let's say it's causing positive current on this side at the same time as causing a negative current on this side. So I didn't consider that when I looked at the physical orientation of the coils. So hopefully that explains why I had to change these dots and why they're correct now. And last but not least, we're going to take a look at this linear map of the windings also, which we've gone over before in previous videos. Right now we're showing where there's zero current being produced in any of the windings. That's because the north face is cutting 16 and 9 at the same time, so they cancel, nothing happens. The north face also cutting 15 and 10 at the same time, so nothing happens. And it's not cutting the other two windings. Therefore, there's no output from this group of four windings. Over here, it's cutting slot 4 and slot 21 at the same time. Therefore, they cancel. It's not cutting the other two windings, 25 and 6 to 19. So therefore, there's no current flowing in this system at this point in time. Same thing happens down here. It's just the opposite polarity. It's the only difference. I'm sorry. I said that wrong. This generator is so confusing. Up here, these happen with opposite polarities, which made the currents add up. Down here is the exact same things happening with opposite polarity between these two. Of course, in this case, there's zero current. But what happens here also happens exactly down here too. They are in phase. The blue windings are in phase with the red windings with reference to the armature. So now let's step the armature. If I can select it. Let's step the armature 90 degrees. 5, 6 positions. And now we're at maximum current. So I'll unhide these things up here. See, now we have the north face of the armature cutting slot 22, which does nothing. But it's cutting 21, 20, 19, 18, 17, 16, 15. All these currents are coming out of the paper, out of the view we're looking at. At the same time, the south face of the armature, which is opposite polarity, is pushing current into slots 3, 4, 5, 6, 7, 8, 9, and 10. So at this point, we have maximum current going up and maximum current going down, but the way they're wired, they support each other. This going up supports this going down, so they're supporting each other. These going down support these going up, so they're supporting each other. And that's how this silly thing works. So having reviewed these particular items, we're now ready to go back into trying to figure out how to connect these windings together. One last thing that needs your attention here is the fact that the windings, this end of the windings in slot 16, this end of the windings in slot 9. In other words, they're not directly across from each other. They're all set by one slot. That allows us to jumper over to the next winding. So if this went back to 15, then you couldn't jump over to the next one. So this one side of the winding in slot 9 goes over to slot 16. So it spans what? 1, 2, 3, 4, 5, 6, 7 slots. It spans 7 slots. This one right here spans 1, 2, 3, 4, 5, 6, 7, 8, 9 slots. And this one spans 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 slots. So this is how we get our harmonic reduction. By changing the slots for each winding, it helps cancel out the harmonics, and that's the main purpose why this was designed this way. So we have to bear in mind that one end of the coil at slot 9 has to be jumpered over to, well, this is a bad example. One end of the coil, slot 3, has to be jumpered over to the other end of the next coil, which is slot 21. So we need these red jumpers to connect these 7 windings together. And it's the same way with the blue power phase. We have these blue jumpers, which same slot variations allow us to generate the total phase voltage. So our problem now is to establish which way the current's flowing through the winding and how to connect these jumpers. So that has to be determined both physical size which is the length of the distance it has to travel, and also the connectivity that has to be made. So we're not out of the woods yet. This is still a difficult process, and I hope to continue at this point and get her done.